August 15, 1977. A volunteer astronomer named Jerry Ehman is sitting at his kitchen table in Delaware, Ohio. In front of him, a stack of computer printouts, each page covered in columns of numbers and letters. He's scanning for anomalies, signals from space picked up by a massive radio telescope called Big Ear. For years, these printouts have shown nothing unusual. Just the random hiss of the cosmos. Then his eyes stop on one sequence. 6 characters. 6 alphanumeric symbols that shouldn't be there. Ehman grabs a red pen. He circles the sequence. And beside it, he writes a single word in the margin. 3 letters. An exclamation of astonishment. Wow! That annotation would give the signal its name. The wow! Signal. It would become the most famous unexplained radio transmission in the history of astronomy. And 47 years later, we still don't know what caused it. This is the story of 72 seconds that changed how we think about what might be listening above us. To understand why Ehman reacted that way, you need to know what Big Ear was built to do. Constructed in the early 1960s on the grounds of Ohio State University, it wasn't looking for planets or stars. It was listening. Specifically, for radio signals that might indicate intelligent life elsewhere in the universe. The telescope was enormous, roughly the size of 3 football fields. Its design used 2 flat reflectors to funnel radio waves from space into receivers. Every day, it scanned a thin strip of sky. Big Ear was part of the early SETI effort. SETI stands for Search for Extraterrestrial Intelligence. The idea was simple: if another civilization exists out there and uses radio technology, we might be able to hear them. Radio waves travel across the vacuum of space. They don't need air. They don't decay quickly. If an alien society broadcasts a powerful signal, intentionally or not, a sensitive enough telescope on Earth might pick it up. That's what Big Ear was designed to detect. A whisper from across the stars. Big Ear didn't move. It was a fixed structure. Instead, it relied on the Earth's rotation to slowly sweep the sky past its receivers. As the planet turned, different sections of space drifted into view. The telescope recorded the intensity of radio signals at different frequencies. Each observation window lasted about 72 seconds, the time it took for a point in space to pass through the beam. Then that point would be gone. The data was printed onto paper, reviewed days later by volunteers like Ehman. The printout used a simple code. Each character represented the intensity of a signal. A blank space or the number 1 meant almost nothing, background noise. The numbers climbed 2, 3, 4, all the way to 9. Then the system switched to letters. A meant 10 times background noise. B meant 11 times. And so on. Most of the printout was just 1s and 2s. Cosmic static. Then Ehman saw it, the sequence 6EQUJ5. The strongest character, U, represented a signal 30 times stronger than background noise. What made the sequence remarkable wasn't just its strength. It was the shape. The signal rose quickly, peaked, then fell away. It matched exactly what you'd expect from a point source in space passing through the telescope's beam. It lasted the full 72 seconds. It appeared in only one of Big Ear's 2 receivers, the one pointed at a specific patch of sky in the constellation Sagittarius. And it was narrowband, meaning it occupied a very tight frequency range. All of this fit the profile of an artificial transmission. There's another detail. The signal appeared near a frequency called 1420 MHz. This is the emission line of neutral hydrogen, the most abundant element in the universe. For decades, scientists speculated that if aliens wanted to send a signal we'd notice, they might choose this frequency. Why? Because any civilization studying the cosmos would be listening there. It's a natural meeting point. A cosmic watering hole. The wow! Signal was found almost exactly at that frequency. That made it even harder to dismiss as random interference. Ehman knew immediately this was unusual. He circled the sequence and added his now famous annotation. But he didn't leap to conclusions. In interviews years later, he remained cautious. He said the signal was the kind of thing we'd been looking for, but he also acknowledged it could have been interference, a satellite, a glitch, something terrestrial. Still, nothing in the data pointed to an obvious Earth-based source. And the signal had come from deep space, far above the plane of our solar system. The question was, what now? The next step was obvious: look again. If the signal was real and repeating, Big Ear should be able to find it. The same patch of sky would rotate back into view roughly 24 hours later. The team aimed the telescope at the same coordinates in Sagittarius. They listened. Nothing. They tried again the next night. Still nothing. They kept trying for weeks, then months. Different telescopes joined the search. Observatories around the world pointed their dishes at that region of space. For years, astronomers returned to those coordinates, hoping to catch the signal again. The signal never came back. Not once. That silence is almost as mysterious as the original detection. If it was a natural phenomenon, a pulsar, a quasar, some kind of stellar flare, you'd expect it to repeat, or at least to show up in follow-up scans. If it was interference from Earth, a plane, a satellite, a military transmission, you'd expect similar signals to appear again. But nothing matched the WOW signal's profile. It stood alone. A single 72-second whisper, then permanent quiet. Despite the caution of scientists, the public imagination ran wild. The WOW signal became shorthand for possible proof of alien contact. Documentaries claimed it was a message. Books speculated about its origin. Some suggested it was a beacon, others a leakage from an alien broadcast. The idea was tantalizing. In 1977, for 72 seconds, humanity might have eavesdropped on another civilization. The story spread. It became one of the most cited cases in UFO and SETI circles. But was it actually evidence of extraterrestrial intelligence? The scientists involved were far more measured. Ehman himself never claimed it was aliens. In interviews, he said he remained skeptical but open. Other astronomers pointed out that a single, non-repeating signal is almost impossible to verify. Without repetition, you can't confirm the source. You can't rule out error. The signal could have been real and extraterrestrial, or it could have been a glitch, a reflection, or an unlucky coincidence. Science demands reproducibility. The WOW signal offered none. That didn't make it unimportant. It made it unexplainable. One-time events are a nightmare for science. Imagine trying to prove lightning exists if you only saw it once and had no camera. The WOW signal is that kind of problem. It was detected, recorded, and analyzed, but never confirmed. This doesn't mean it didn't happen. The printout is real. The data is there. But without a second occurrence, it exists in a strange limbo. Too strong to ignore, too isolated to confirm. It's a data point without context. A single breadcrumb in an infinite forest. Over the years, scientists proposed natural explanations. One candidate: pulsars. These are rapidly spinning neutron stars that emit beams of radio waves. As they rotate, the beam sweeps across space like a lighthouse. If Earth happened to be in the path for just a moment, we'd see a brief, strong signal. But pulsars typically repeat. They're periodic. The WOW signal didn't fit that pattern. It appeared once, perfectly, then never again. A pulsar would have shown up in subsequent scans. This one didn't. Another theory involves interstellar scintillation. Radio waves passing through clouds of interstellar gas can be bent, focused, or amplified like light through a lens. Perhaps a distant, continuous signal was briefly magnified by a chance alignment of gas clouds, making it appear strong for just 72 seconds, then fading back to undetectable levels. It's possible. But it's also highly speculative. There's no direct evidence of such an alignment in that region of space at that time. It's an explanation that fits the data only if you assume a remarkable coincidence. Then there's interference. Could the signal have come from Earth? A satellite, a passing aircraft, a secret military transmission? Big Ear's design made this unlikely. The telescope's beam was pointed away from the horizon, reducing ground-based noise. The signal appeared in only one receiver, suggesting a precise directional source. And it was at a protected frequency. Radio transmissions near 1420 MHz are internationally restricted to prevent interference with astronomy. None of the usual suspects fit. But unlikely isn't the same as impossible. We can't rule it out completely. In 2017, a new explanation emerged. Astronomer Antonio Paris proposed that the signal might have come from comets. Specifically, two comets, 266P/Christensen and P/2008Y2, that were in the same region of sky in 1977. Comets release clouds of hydrogen gas. When stimulated by solar radiation, that hydrogen can emit radio waves at 1420 MHz. Paris argued the wow signal could have been natural hydrogen emission from one of these comets, which just happened to be passing through Big Ear's field of view. It was a tidy, naturalistic explanation. The comet hypothesis got widespread media attention. But it didn't convince everyone. Other scientists pointed out problems. The signal was far stronger than typical comet emissions. The frequency match wasn't exact, it was close, but not identical. And Big Ear had been scanning the sky for years. If comets routinely produced signals like this, the telescope should have seen others. It hadn't. Ehman himself was skeptical, noting the hypothesis relied on assumptions that weren't well supported by the data. The comet theory remains a possibility, but it's far from proven. Here's what we're left with: an extraordinary signal, documented and real, with no definitive explanation. And maybe that's okay. Science doesn't always give us neat answers. Sometimes the most honest response is, we don't know yet. The wow signal isn't proof of aliens, but it's not proof against them either. It's a reminder that the universe is full of phenomena we haven't cataloged, processes we haven't discovered, events we can't predict. It's a 72-second gap in our knowledge. And that gap is humbling. The search didn't end with the wow signal. If anything, it intensified. Modern SETI projects use arrays of telescopes, scanning millions of channels simultaneously. They monitor the sky constantly, looking for patterns, repetitions, anything that stands out. Projects like Breakthrough Listen have cataloged billions of signals. None have matched the wow signal's profile. But the search continues, because the question it raised is too important to abandon. Are we alone? Or is someone out there, broadcasting into the void, hoping someone like us is listening? The wow signal revealed something about humanity. When we saw that printout, we wanted it to be aliens. We wanted proof we're not alone. That desire says something profound. We're a species that looks up, wonders, and hopes. We build enormous machines to listen for whispers across unimaginable distances. We dedicate careers to questions we may never answer. The signal may have been a comet, a glitch, or something we haven't imagined yet. But our response to it, the decades of searching, debating, hoping, that tells us who we are. We also learned about our limits. Big Ear was cutting edge for its time, but it was primitive by today's standards. It recorded on paper. It scanned slowly. It couldn't revisit a signal in real time. If the wow Signal happened today, modern telescopes could slew instantly to the source, record it at higher resolution, alert other observatories worldwide. We'd have follow-up data within minutes. In 1977, we had one printout and a 72-second window that closed before anyone knew it was open. Technology matters. Timing matters. Sometimes, the universe only gives you one chance. Beguier kept listening until 1997. Then it was dismantled. The land was sold for development. Today, the site is a golf course. The telescope that heard the most famous signal in SETI history no longer exists. There's a small memorial marker, but otherwise, nothing remains. It's a strange footnote. The instrument that might have detected the first evidence of extraterrestrial intelligence was torn down to build fairways and greens. Progress, economics, and cosmic mystery don't always align. Beguier is gone. The signal it heard remains unexplained. The original printout still exists. It's been digitized, analyzed, and reproduced countless times. You can find images of it online. Ehman's red ink still visible, the sequence 6EQUJ5 circled, the word WOW scrawled in the margin. It's been displayed in museums. It's been cited in hundreds of papers. That single sheet of perforated computer paper has become an icon. Not because it proves anything, but because it asks a question we can't stop thinking about. It's a frozen moment of wonder. And it still makes us wonder. The WOW signal isn't the only unexplained radio event. In 2007, astronomers discovered fast radio bursts, intense pulses of radio waves lasting milliseconds, coming from deep space. For years, their origin was unknown. Eventually, some were traced to magnetars, highly magnetized neutron stars. Others remain unexplained. Then there are peritons, signals once thought cosmic but later revealed to be microwave ovens in the observatory kitchen. The universe is noisy. Separating the genuinely mysterious from the mundane is harder than it sounds. The WOW signal sits somewhere in that ambiguous space. In 1961, astronomer Frank Drake proposed an equation to estimate the number of active, communicative civilizations in our galaxy. It includes factors like the rate of star formation, the fraction of stars with planets, the number of habitable worlds. The equation is more philosophical than mathematical. Most of its variables are unknown. But it frames the question, how many signals might be out there, waiting to be found? The WOW signal suggests the answer might not be zero. But it also suggests those signals might be rare, fleeting, and maddeningly difficult to confirm. If we ever do detect an unambiguous alien signal, what would it look like? Scientists expect it would repeat. It would have structure, a pattern, a modulation, something clearly artificial. It would appear at multiple telescopes, confirmed by independent observations. It wouldn't be a single 72-second blip that vanishes forever. The WOW signal fails most of these tests. That's why it's frustrating. It has some of the hallmarks of an alien transmission, but none of the confirmability. It's a tease. A cosmic maybe. And maybe, in the end, is all we have. The WOW signal touches on a deeper puzzle, the Fermi paradox. Named after physicist Enrico Fermi, it asks, if the universe is so vast and old, where is everybody? If intelligent life is common, we should see evidence everywhere. We should be drowning in signals. Instead, we have silence and one ambiguous blip from 1977. Maybe civilizations are rare. Maybe they don't broadcast. Maybe they exist but are too far away, or we're looking at the wrong time. Or maybe we heard one, once, and didn't realize it until it was too late. Here's an uncomfortable thought. What if signals like the WOW are common, but we keep missing them? Most of the sky isn't being monitored most of the time. Even with modern arrays, we're sampling a tiny fraction of the radio spectrum at any given moment. If an alien civilization sends a brief, powerful pulse, maybe a ranging beam, a test, or a misdirected transmission, and we're not looking at that exact frequency at that exact moment, we'll never know. The wow signal might not be unique. It might just be the only one we happen to catch. Some scientists argue the great silence, the absence of detected alien signals, is itself an answer. Maybe civilizations destroy themselves before they become detectable. Maybe advanced societies abandon radio and use technologies we can't imagine. Maybe they're deliberately quiet, avoiding contact. Or maybe intelligence is an evolutionary fluke, and we're alone. The wow signal complicates this. It's not proof of contact, but it's not proof of silence either. It's a question mark in the data. A reminder that absence of evidence isn't evidence of absence. Jerry Ehman is still alive. In interviews over the years, he's remained humble and cautious. He said he'd give the wow signal a 7 or 8 out of 10 on the probability scale of being extraterrestrial. Not certain, but not dismissive. He acknowledges we may never know. He doesn't claim discovery or fame. He simply did his job. He saw something unusual, he marked it, and he reported it. The fact that it became one of the most famous signals in history is almost incidental. Ehman's quiet professionalism is a reminder that good science isn't about grand claims. It's about careful observation. Let's be clear, the wow signal is not proof of aliens. It's not a message. It's not a confirmed extraterrestrial transmission. Those are myths, inflated by headlines and wishful thinking. But it is a genuine mystery. A strong, well-documented signal that fits some criteria for artificial origin and has never been explained. Myths distort. Mysteries invite. The difference matters. When we treat the wow signal as proof, we stop asking questions. When we treat it as a mystery, we keep searching. And the search is the point. The wow signal taught the field of radio astronomy important lessons. It showed the need for real-time follow-up capability. It revealed gaps in our monitoring coverage. It underscored the importance of archiving data. Without that printout, the signal would have been lost forever. Modern SETI projects now use automated alert systems. When a candidate signal is detected, multiple telescopes can slew to the source within seconds. We've learned to record everything, redundantly. The wow signal was a wake-up call. We weren't ready for it in 1977. We're more ready now. Ehman was a volunteer. He wasn't a tenured professor or a full-time researcher. He was a citizen scientist, donating his time to review printouts. That's how the most famous signal in SETI history was discovered. Today, projects like SETI at Home let millions of people contribute computing power to analyze radio telescope data. Anyone can participate. The next wow signal might be found by someone in their living room, scanning data on a laptop. Science isn't just for professionals. Sometimes, the most important discoveries come from people who simply care enough to look. Here's the the wow signal isn't important because it proves aliens exist. It's important because it proves we're listening. For 72 seconds in 1977, humanity's technology was good enough to detect something extraordinary, whatever it was. That's progress. A century earlier, we wouldn't have noticed. A century from now, we'll have instruments that make Big Ear look like a tin can and string. The signal may remain unexplained, but the fact we heard it at all is a milestone. We become a listening species. And the universe, for one brief moment, spoke. 47 years later, the wow signal still appears in textbooks, documentaries, and debates. Why? Because it represents the best kind of mystery, one grounded in data, resistant to easy answers, and open to future discovery. It's not a ghost story. It's not folklore. It's a printout you can hold, a sequence you can analyze, a question you can investigate. And it reminds us that the universe doesn't owe us explanations. Some questions take decades. Some may take centuries. Some we may never answer. But we keep asking. Step back, and the wow. Signal is a single data point in a much larger story. Humanity's first serious attempt to listen to the cosmos began in the 1960s. We've been at it for about 60 years. The universe is nearly 14 billion years old. We're infants in this search. We've scanned a fraction of the sky, at a fraction of possible frequencies, for a cosmic eye blink. And in that tiny sample, we found one signal we can't explain. Imagine what we might find if we keep looking for 1,000 years. Or 1,000,000. Here's the final takeaway: most of what's above us is still unknown. We've mapped a sliver of the radio spectrum. We've cataloged a fraction of the stars. We've searched for life in ways that assume life is like us, using radio, at frequencies we think are logical, during the brief window we happen to be listening. The wow! Signal is a reminder of how much we're missing. Every day, signals might be washing over Earth that we don't have the tools to detect, or the knowledge to recognize. The cosmos is vast, strange, and mostly unexplored. Imagine tomorrow, a telescope detects a signal like the wow. Strong, narrowband, repeating. Protocols exist for this. The signal would be verified by multiple observatories. The data would be released publicly. Scientists would analyze it for patterns, content, intentionality. Governments would be notified. The United Nations has a framework for responding to extraterrestrial contact. It sounds like science fiction, but the plans are real. And if it happens, the wow! Signal will be remembered as the warning shot. The moment we almost knew, but couldn't quite confirm. The rehearsal for the real thing. Ultimately, the wow. Signal endures because it touches something deep in us. We want to know. We want to believe we're not alone. We want the universe to make sense, or at least to speak to us in a language we can decode. That desire drives science, art, religion, every human attempt to find meaning in the unknown. The signal might have been a comet. It might have been interference. Or it might have been exactly what we hoped. We don't know. And the not knowing is what keeps us looking up. In the end, the wow. Signal is a 72-second question that has echoed for nearly 5 decades. It changed no equations. It confirmed no theories. But it reminded a generation of scientists and dreamers that the universe is full of surprises. That our tools, however sophisticated, are still crude. That we live in a cosmos we barely understand. And that somewhere, in some direction, at some frequency, something might be broadcasting. We might hear it tomorrow. We might never hear it again. But we'll keep listening. Because we're human. And we wonder. August 15, 1977. A printout. A red pen. One word in the margin. Wow. It's one of the simplest annotations in the history of science, and one of the most enduring. Jerry Ehman couldn't have known his scribbled exclamation would become shorthand for the mystery of cosmic silence, the hope of contact, and the humility of not knowing. The signal came. The signal went. And we're left with a question that might outlive us all: what was it? Maybe someday, we'll know. Until then, we have 72 seconds of data, a fading printout, and the knowledge that above us, the universe is still full of voices we haven't learned to hear.